Welcome to the third day of 5-day web services programming code camp from jpassion.com. Today we are going to focus on two major topics. The first one is JAX Web Services. So these are the 5 topics we are going to cover. Actually, we probably cover just 4 topics and possibly Sage, because that's a topic that we were not able to cover yesterday. And then the next major topic is data binding, which is JAX-B. So we are going to cover JAX-B Basics, which is based on JAX-B 1.0, and then we are going to cover JAX-B 2.x. Okay, so let's move on with the JAX Web Services Basics presentation. All right, JAX Web Services Basics. So we are going to go over JAX Web Services quickly and the concept, and then we are going to move on to the programming model. So we're going to learn the layered programming model, and we are going to see how we can write the server-side JAX Web Services programming programs. We already have an exposure to an annotation at web service annotation, so we can actually move on a bit more detail, and client side as well. And then we're going to talk about protocol and transport independence. And then we're going to actually move on a bit more detail on each of the annotations that are available in JAX Web Services specification. And then we're going to talk about the tools. And then finally, the topic we're going to cover is a client catalog file. So quick overview of JAX Web Services 2.0. So it provides simpler way of developing and deploying web services compared to older version. By the way, older version used to be called JAX-RPC 1.0, and then they changed the name of the spec to JAX Web Services. So these two are the same thing. Okay. So in JAX Web Services 2.0, basically you create a POJO, and then all you have to do is to use annotation to expose it as a web service. So yesterday we were able to just create a POJO, and then all we have to do is to use at web service annotation at the class level, and then that was only thing you have to do to expose it as a web service. There is no deployment descriptor needed, as you have guessed, unlike JAX Web Services 1.0, because annotation handles everything for you. And it also provides layered programming model, and we're going to talk about what that means in the following slide. Java platforms that support JAX Web Services. So Java platforms that support JAX Web Services 2.0 could be either Java SE 6 version 4 and after, or Java EE 5. So far what we have done is to use Java EE App Server platform to deploy your web service, but you should be able to deploy your web service using just a standard Java SE, and we're going to actually talk about it in a separate presentation. It does use JAX-B 2.0 as a built-in data binding. So by data binding is a translation between Java objects to XML and XML to Java. Okay, so it's using JAX-B internally to do this data binding. And protocol and transport independence. By protocol and transport, we are talking about by protocol. You're talking about mostly SOAP. Here you can specify SOAP 1.1 or SOAP 1.2. SOAP 1.1 is the default, and if you want to use a SOAP 1.2, you can specify an annotation, binding annotation that indicates that you want to use a SOAP 1.2. Transport independence, you can specify a different transport other than HTTP, but we are going to mostly focus on HTTP as a transport. Layered programming model. So what do you mean by layered programming model? So JAX Web Services provides 2 different layers for the developers to write a web service. So developers write application code. Typically, the developers will use the first layer, which is strongly typed layer, basically annotation based. Okay, so this is what we are going to mostly focus on. And it also provides a lower level layer, which is called the messaging layer, which provides a dispatch and provide interface. And these annotation classes are in fact built on the top of it. Okay, so just to give a bit more detailed information. So what does it mean? What does it mean to have these two different layers of programming model? So that upper layer that we talked about, this guy, this layer, uses annotation extensively. So obviously it's a lot easier to use for developers to build and deploy web services. And it provides greater toolability. So because of annotation can be kind of detected by IDEs and tools, it actually provides the better tool support. And fewer generated class. So this is probably not a big deal to the developers because it's done internally, but compared to old version, it does actually generate fewer classes. The lower layer is more traditional, so this is like a JAX Web Services 1.0 or JAX RPC 1.0. So it is API based, meaning it's not annotation based. It could be used for advanced scenarios, okay? For like async support and things like that. Most applications are going to use upper layer only. Okay, again, that's what we are going to focus on. And either way, the portability of application is guaranteed because annotations as well as APIs are standardized in JAX Web Services specification. All right, so let's go over how to build web services on the server side. So this is something that we talked about a couple of times. You can create a web service in two different approaches. One is called contract first or top-down approach. They are the terms that are used interchangeably. So contract first meaning you start with a WSDL document, meaning you create XML schema along with WSDL, which includes that XML schema. And from the WSDL, you are going to use a tool, for example, WS import, to generate skeleton code. So it will generate web service interface, web services Java interface, and web services Java implementation skeleton class. And then you're going to add business logic to this web services implementation skeleton code. So this start from WSDL document and then write Java code. That is contract first or top-down approach. The other approach is contract last or bottom-up approach. And here you start with the Java code. So you're going to write the Java code and then you're going to use annotation. And that annotation is going to be used by the tools to generate everything that is needed, including WSDL documents. So here, WSDL document will be generated. And the tool that is being used at the command line or within the IDE is in fact using WSGen utility that comes with JDK. And that is for generating WSDL document from Java code. So WS import and WS gen, this comes with the JDK. So if you just type WS import on the command line, you should be able to see the help screen. And WS import is used to generate Java code from WSDL document. And WS gen is to generate WSDL document from Java code. So WS import is used for the top-down approach, and WSGen is used for the WS import is used for the top-down approach, and WSGen is used in contract class or bottom-up approach. Okay, so we are going to actually talk about how you can do server-side web services development. Here we are going to actually do contract last, meaning bottom-up approach. So we are going to write Java code and use annotation, and then we are going to deploy. So this is something that you have done already yesterday. Okay, so you write Java code, and then you are going to use add web service annotation to it. And optionally, you can inject web service context object. And then you deploy the application, And WSDL document, as part of the deployment, WSDL document will be generated, and the WSDL document can be accessible through as a convention. It's not a requirement, it's a convention for JAX Web Services implementation. And so WSDL document can be given to client, and client should be able to access that web service. Okay, so this is something that we have seen yesterday, right? So you write the POJO class. In this case, it has a very simple method add, which will be exposed as a web service operation. Okay, so when you do use at web service annotation at the class level, that means all public methods of this particular class will be exposed as a web service operation. So here we have only one single method, so there will be only one single operation. And WSDL and schema will be generated automatically, and during the generation, default values will be used. Okay. The default values meaning what is the target namespace, what is the name of the service, what is the name of the port type, and things like that. And obviously, you should be able to customize those things. And we are going to learn how we can do customization later on in this presentation. Okay, so this is you can actually build web service endpoint in 3 different ways. One is servlet based, which is what you do here. And you can deploy, you can actually create the web service based on EJB. So this is what you do. So suppose this is the EJB code. And then all you have to do is basically, again, using at web service annotation. The reason you might want to deploy your web service based on EJB as opposed to servlet is for the same reason why you want to use EJB. The reasons that you want to use the EJB is to use EJB's built-in features such as transaction security, interceptors, and things like that. So when those features are important for your web service endpoint, then you can build your web service based on EJB. Okay, so what is a web service context? This is optional. If you want to have an access to some internal information such as a security information, you can call, in fact, get user principal method to get the principal object representing the client. You can get the message context. In the future, this web service context object could be used to include other information about the client and service. Okay. Now, in order to inject this web service context object, you can use @resource annotation. Okay. And the message context object that is available from web service context object is a backup property. So it could be actually the data, which is not part of the payload. And it might actually include some of the query string and things like that. So customization through annotation. So this is at web service annotation, and then you can actually provide the attributes to do some customization. So here I like to use this credit rating service as the name of the service instead of just this as a service. And this is the target namespace I like to use. This is for each method. Okay, so we're going to actually learn these things in a bit more detail later on. This just to show you that you know customization is possible. So web method can be used for each method. Okay, so here instead of using get credit as the operation name, you can actually specify different operation name. And this is for customization of your parameter. Okay. Again, we're going to actually learn about this annotation in detail later on. All right, let me actually make sure the recording is done okay. So, right. So that is a server-side programming, and you're going to actually talk about the client-side programming. Again, we talked about this one already a couple of times. So we are going to actually learn how we can do web services client programming on Java EE platform. So your Java EE platform could be playing the role of web service client, okay, or the web service client could be Java SE application. So here, if you want to write your web service client in your Java EE platform, for example, within your servlet or within your EJB code, this is what you can do. First of all, you are going to create the Java code using WSDL. So again, this is a top-down approach. and you are going to actually use either a tool like a NetBeans or Eclipse, or you can just use WS import at the command line. So basically what you say is WS import and give the location of your WSDL document. Okay, and you can specify where is the destination of your code supposed to go, and the package and things like that as well. That's a deep. And then you're going to yeah. So basically, this is generating uh, um, uh, and then yeah, basically, you actually have. So basically, what it does is generate. Yes, we are talking about the. Uh, one thing I didn't mention is that WS import is used also to generate the client-side code. Okay, so I talked about usage of WS import on the server side, in top-down approach, but you can also use WS import for creating client-side stub code. Okay. So it will generate annotated class and interfaces, and that's basically library stub code. And then you can actually inject web service reference of annotation on an appropriate type, and then you can invoke any remote operations. Okay. All right, so this is basically what you do in Java EE-based web services client. You are going to use this annotation, web service reference, and then you provide the name of the service. Okay, and then all you have to do is just providing an interface, and then it's a proxy, and that you can use it right away. So this is a lot simpler than the code that you have to write in Java SE, as you are going to see in a few seconds. Okay, because when you do use web service reference with the name of the service class object, and then provide a proxy, the client stub code is in fact will be generated for you. Okay, so Java SE client programming is pretty much the same deal. Okay, then you are going to actually, these steps are different. So you're going to actually you have to create a service object yourself. Okay, and then you're going to create the stub object or proxy object using the name of the service, the port method of the service object, and then you can actually invoke remote operation. So in this case, you have to create the service object yourself first, and from the service object, you're going to get the proxy object or stub object, and then once you get the stub object, you can actually call the method. Okay. So if you compare Java SE-based web service client programming from the Java EE-based, okay, this is a bit simpler because the service object will be created by this annotation for you. Okay, and then you can just use a proxy right here. Okay. All right. Oops. So we're going to actually do exercise 1, which is, again, this is the contract last and bottom up approach. Okay, so let's take a look at the lab documentation. So here we are going to just open the NetBeans project and run it. Okay, and later on we are going to actually build this application step by step from scratch. But for now we are going to just run the application and see how it behaves. Okay, so the first application is from Java server and from Java client. So obviously from the name you can make a guess. This is a contract last, meaning we are starting from Java code, and then WSDL gets created from it, and as far as the client is concerned, it doesn't really matter whether that is the service is created from the top-down approach or bottom-up approach. As long as a WSDL document is created, client will be able to access it. So client doesn't have the concept of contract last or contract first, okay? Because client has to have a WSDL document always. So when we say contract last and contract first, or bottom-up or top-down approach web service, you're just talking about the server side. Okay, so let's open this from Java server. So when you run the application, you're going to actually see this WSDL document will be displayed as a default. Okay, and then you can verify whether web service is deployed on the services, of course. Okay. By the way, in this case, the web service is actually being deployed as a web application. So it's a servlet based. Okay. And then you can test the web service as we have done yesterday. Okay. And make sure this add number implementation works okay. So you should be able to observe the result. And then you are going to take a look at the code. Okay, so code is pretty simple. So again, this is pretty much the same as we have seen yesterday with the Hello World web service. We are using @web service annotation at the class level, which means all the public method in this class will be exposed as web service operation. Okay, and you can throw the add number exception. So whenever there is an add numbers exception, it will in fact generate the SOAP fault message. Okay, so this is an example where we are dealing with an exception as well. Okay, and so that's the server side, and from the client side, it's going to it is going to get the WSDL document. So when you refresh it, okay, when you refresh it, it's basically trying to get the new WSDL document from the location it knows about. Okay, and then is going to then you're going to be able to clean and build, and you are going to see you're going to see WSDL document is downloaded, and then new stuff will be generated, and then you are going to be able to run it, and this is what you are going to see. So client code is pretty much the same as we have seen on yesterday on the Hello World. Okay, one thing that we haven't talked about the concept of the catalog, so don't worry about this one. We're going to actually talk about this concept later on. Okay, so just study the Java code. So here we create the service object first, and then we call the get add numbers input port. So we get the port or proxy or the stub. Those are all same things. So we got the proxy object, and then you should be able to call the method of that proxy object. Okay, and you can see these are generated code. So these are the generated code from WSDL document on the client side. So client side, in this case, NetBeans uses WS import to generate the client-side stub code. Okay, and then you should be able to capture SOAP traffic using WS monitor. So this is pretty much the same drill as we have done yesterday. Okay, and you have to change the client code so that client now sends the request to port 4040 instead of 8080. Okay. And then when you run the client, you should be able to capture the traffics. Okay. Again, if you see this network connection problem, that means somebody else is using the port 8080, so you might want to close all the applications that uses that port 8080 and then try again. Okay. Let's see. Yeah. So this is something to do with the port number issues. And you can take a look at the generated artifact on the server side. The WSDL gets generated as part of the deployment. So again, this is the WSDL document that we were able to see, right? And you can see as a default, it generates document style, and it's using literal encoding scheme, okay? And it also generates XML schema. So if you see, it actually import the XML schema. It imports XSD1 here. So it's basically the XML schema. So this is actually what gets, if you actually go over here, if this link, okay, you can see it generated XML schema in which it has the definition of several complex types, including, in this case, exception, and then several global elements, okay? And again, you can do context-sensitive Java docking on @web service annotation, and you can find out more about the web service annotation. Okay. Okay. So as I mentioned, this is a bit of the similar drill as we have done yesterday when we did build Hello World web service. Okay. But this is a bit more detail. So I'm going to give you guys about the 10 minutes to try this exercise. Next one is protocol and transport independence. So protocol and transport independence could be actually specified using annotation, again, when you're using the bottom-up approach. Okay. Typical application code is protocol agnostic. The default binding to use is SOAP 1.1 over HTTP. Okay. If you want to use a different binding, for example, different SOAP version number, then we are going to use binding type annotation at binding, and here this is going to specify the that I'm using. I like to use SOAP 1.2. Okay. So if you want to use JMS, it's possible that you can use binding type that indicates that you want to use JMS, for example, or SMTP. Okay. But I don't think there is actually a notation that is available for JMS support or SMTP for now. Okay, so that's something that I should actually check using the. Let's take a look at whether there is a JMS or the SMTP binding available right now. It wasn't before. Okay, but I'm almost sure it's not there either. So we'll take a look when we do the lab. Okay. And the client must use binding specified in WSDL document. So once WSDL document is created, when you're actually using this annotation indicating that you want to use a SOAP 1.2, corresponding the indication is going to be specified in WSDL document, meaning WSDL document is going to be created reflecting SOAP 1.2. Okay. So client, when it reads WSDL document, then it knows that it has to use SOAP 1.2. Okay. So again, bindings are extensible, so expect to see this kind of JMS or SMTP binding in the future. But as I said, I'm not sure it's there. All right. So this is the way that you are going to specify binding type. Okay. So binding type and SOAP binding.SOAP 1.2 HTTP underscore binding. So let's do exercise 2. So exercise 2 is let me show you the documentation. And so basically it is exactly the same code, but we are adding binding type. Okay. And client is working exactly the same as well. Okay. And you can take a look at the in this case, this is something I'm not sure we should do or not. So we can just take a look whether edit web service attribute and extension is set to true or not. Okay, and this is WSDL document. So basically, important thing is this guy. Okay, it's using SOAP 1.2 namespace. Okay, and for any binding, it's actually using SOAP 1.2 prefix namespace. Okay, and the web message itself should the SOAP message itself should reflect the new namespace. Again, this is the namespace that is used as a version number. Okay, so remember yesterday, if you're using the SOAP 1.1, yeah, so that you should be able to see in the exercise 1. So in exercise 1, when you see the SOAP message, you are going to actually see it's using 2001 SOAP message. Okay, let's see. I think yeah, if you capture using WSD, yeah. So if you actually capture this guy, you probably see right here. Yeah. So this is actually SOAP. It doesn't say anything about the 2001 here. That is indicating this is SOAP 1.1. Okay. And yes, I think I was actually talking about the WSDL yesterday. Okay. So if you're actually seeing a different URL, so if you go to exercise 2, the SOAP message you're going to see is like this. Okay. So it's different from SOAP 1.1 namespace, and that's the way the client and server knows what version they're actually talking about. Okay. So if the SOAP 1.2 server receive a message that contains the SOAP 1.1 namespace, and then again, as we talked about yesterday, it might actually send the version mismatch fault code. Okay, and so everything else is pretty much the same. Okay, except that the so let's actually, I'm going to see whether I'm gonna see Java documentation to see whether there are any other bindings except the SOAP 1.2. Okay, so I'm gonna open it, open the project, and this is the project of this lab. And so on the 2 server, yeah, the reason clients have the compilators is because I have not generated code from WSDL yet. Okay, I'm gonna go to the source package right here, and this is import. So as you can see, we have a binding type. Okay, so I'm gonna take a look at the Java documentation of binding type, if there are any new bindings defined. Okay, besides SOAP 1.2. Okay, so yeah, looks like that's the only one. Yeah, so oh, it has the HTTP binding. So it's in this case there are 3 bindings. One is SOAP 1.1 over HTTP binding, SOAP 1.2 over HTTP binding, and HTTP binding is basically you are sending a SOAP message over just HTTP. I'm sorry, you are sending just the XML over HTTP without using SOAP. Okay, so these are only 3 bindings that are available. Okay, so I'm going to give you guys about 7 minutes to try this exercise. Resume. So here we are going to learn JAX Web Services annotation in more detail, including some customization. So this is something that we have already learned. We use this web service without any attributes. Okay, so as we talked about, when you're using web service at the class level, that means all methods of that class will be exposed as web service operations. By the way, you can actually use this web service at Java interface as well. Okay, so you could use that web service annotation at the class level or an interface level. Okay, and these are attributes. So if you're using endpoint interface, it's basically you are using when you're using web service at implementation class, you can also specify the interface of that particular implementation class. And this name is mapped to port type, and this port name is mapped to port, and the service name attribute is mapped to service, and the target namespace is for creating target namespace. And if you have a WSDL location, you can specify WSDL location as well. So in this case, it's not going to generate WSDL document. Instead, it's going to just use it. All right, so web method is for customization of a method that is exposed as web service operation. And you don't have to actually throw remote exception. And attribute, you can specify the when you're using action, and it will set the SOAP action header. Exclude, if you're using exclude, that means you want to exclude this particular method being exposed as a web service operation. So this is typically used when you use web service annotation at the class level, which means all the methods, public method in that class will be exposed as web service operation. But if you want to exclude the one method from the being exposed as web service operation automatically, then you can use exclude attribute. And operation name is specifying different name for operation name that is going to be used in generating WSDL operation. Web param is used for mapping individual parameter to a web service message part and XML element. Okay, so you can specify various attributes like a name, part name, target namespace, header, and mode. So this is an example where you are using web service and web method and web param annotations. So here we are using web service annotation with the target namespace attribute and the name attribute. Okay, so here instead of taking this guy as a name, is taking add numbers as the name of the service. And here we are annotating add numbers method with add web method annotation. This is the name of the operation that we like to use. This is an action which will be set the SOAP action header, and this is a result. Okay, so result name is going to be return. Okay, instead of add numbers response. That's the default. But if you want to use a different name, then it's going to be set with add web result annotation. And these are web param annotations, the annotating these parameters, okay, with this name. Okay, so let's do exercise 3 and 4. So exercise 3, we are going to play around with all these annotations. And exercise 4, we are going to actually build from the scratch, step by step. Okay, so let's take a look at the documentation. So here we are going to exercise a web service annotation. So binding, this is something we already have done it. And then the web service, web method, and web result, and web params. Okay. Yeah, one thing I didn't really specify is, didn't talk about so binding is that you can specify the style. The default style is document, right? But if you want to use a different style, you can actually use this style to give RPC style. There are only two styles, RPC style and document style is the default. Same thing for encoding. So the literal is the default. Okay, so if you don't specify anything, then it will use literal. But if you want to use different encoding, then you can specify different encoding. Okay. All right, so if you're running annotation server, and then you can test the web service, and then you can take a look at the web service annotation. So here we can specify endpoint interface is providing what is the Java interface for this implementation. And we have same method add numbers and the throwing add numbers exception. Okay. And so instead of actually throwing RMI exception, which is kind of low-level exception, you are basically throwing application level exception like this. Okay, and then interface, we are specifying bunch of the annotations. So web service, and this is target namespace we like to use. This is the name of the service, and this is a SOAP binding. And then we are going to specify web method. So the name of the operation we like to use, instead of add numbers, we want to use add. And this is the SOAP action header we'd like to set. And this is the web result. So this is exactly the same code we have seen in the slide. So I'm going to actually move forward. Okay. And client should be working exactly the same. So, the client, as long as it has the WSDL document, it should be able to just access the web service. So the client code is exactly the same. Now, in terms of generating artifact, as you can see, it generates the namespace. That is actually, this is the namespace, and this is the location of WSDL, and then generated artifact is literal, and the style is RPC. Okay. And then this is the WSDL document. So this is the abstract part of the document. You remember yesterday we were talking about the authoring style of WSDL. So in general, it is recommended to create three different parts. One is the XML schema. The other one is the abstract part of the visual document, and then concrete binding part. So this is actually concrete binding part, right? Which import the abstract part. So abstract part is this guy, right? So when you actually go over there, then you're going to see this abstract part of the visual document, right? And this guy is actually importing schema. Okay, so that schema is, again, should be able to accessible, the same link, and this is the schema. And you can take a look at the captured SOAP message. Okay. All right, so that's exercise 3. Now, in exercise 4, we are going to build the application step by step. Okay. So here we are going to create a new web application. So we are basically building servlet-based. I should say web-based web service instead of the servlet-based web services. Okay, because that's web-based is actually more the appropriate name. Okay, so here we are going to create a web application called Annotation Server My Own. Okay, and then yeah, you can just give any project location you want, and choose Glassfish 4.0 and choose Java E5 or 6. Okay, and then we are going to get the source code. So basically, we are going to copy this annotation.server package. We're going to just copy the package, okay, from the that project, and then we paste on the source package under annotation server my own. Okay, so we're just using the same code. Okay, and then all you have to do is just deploy. Okay, because annotations are going to be interpreted by the NetBeans, and it will generate all needed pieces, including WSDL. Okay, and then you can certainly test the code to see whether it gets deployed correctly. Okay, and it should work as it is. All right, so that is and then you can compare the annotations with the WSDL document. So here you can compare. This is how you specify the target namespace and the name of the service. Okay, so you can actually see the generated WSDL should use the namespace target namespace that I specify. So it is colored with red colored. Okay, so this one and this one. And the name of the service should actually match the port type. Okay. And in terms of the binding, so RPC, you can see I'm using RPC style. So this is red colored. And in terms of literal, again, literal is specified here. We're going to talk about the parameter wrap later on. Okay. And here you are going to compare web method annotation. Here an operation name is add and action is add numbers. So here you are going to see the operation name is add. Okay, and this one is basically setting the SOAP action header. So this is basically in WSDL. This is actually how you're going to actually specify, and then this will be used in the SOAP header. Action header. Okay, and this is the web result return, and again this is the name of the response, part name actually. Okay, yeah, so looks like I actually I gave you misinformation. So message name is still add, and add response is actually the part name that we are actually specifying. Okay, and these are web parameters. Okay, so you can see how they are actually related. Okay. And then you can actually create the web service client, and it should work exactly the same. Okay, nothing much different. Okay. All right, so I am going to give you 15 minutes to do this exercise. Next is how we can develop JAX web services application, which is actually using complex type. So far, the method and parameter types that method uses are primitive types like an int and string and things like that. But in general, you want to actually build your application using custom data type, like a person or address or a purchase order and things like that, rather than just int type. Okay, so that's what we are going to actually learn here. So basically, underneath, data binding happens by JAX Web Services using JAX-V. Okay, so JAX Web Services handles the data binding of primitive types between Java and XML. However, for complex data types, you'll have to give an instruction on how to do it using XML element and other JAX-V annotations. So here we're going to just use XML element for creating the XML data types from Java classes. So this is XML element. So here, if I want to, so basically I want to map Java Beans property. So in this case, I want to this is the US price class, and then I want to map this price Java bean. I'm sorry, the what am I talking about? Yeah, so this is XML element, and I want to actually map this one to an sub-element of US price like this. Okay. So maps a Java beans property to XML element derived from property name. Okay. The as a default is going to use the XML type. That's something we're going to actually learn later on. Okay. So this is an example where XML type is kind of assumed, and here we are using XML element to map this the Java beans property to an XML element like this. Okay. So let's do exercise 5. So this is a bit more complex type that we just have seen in the slide. Okay. So here we are going to build supply chain server web services, supply chain web services, web service, and so we have warehouse import web service. Okay. And then we have a method called what is the method? Submit PO. Okay. So this guy is actually accepting purchase order class object, and then is returning shipment notice, the type. Okay. So obviously these guys are a custom data type. Okay. Which is supposed to be handled as a complex type. Okay, rather than simple type examples we have seen so far. Okay. So the logic here is not that much important. Here basically we created shipment notice object and then we just return it. Okay, so what's important is that this method is accepting purchase order object and then returns shipment notice object, which are the custom data type. Okay, so let's take a look at the purchase order Java file, which is actually defining purchase order. Okay, so here we have string and custom number. Those are primitive types, so they are going to be automatically kind of translated. And then we have a list of item object. Okay, so in this case, item is again another class. Okay, so item is basically now we have set of strings and set the string and int type and things like that. Okay, so here we are basically using XML element to map this list of item to the purchase order complex type. Okay, so and then this is a shipment notice type. Okay, so again, it actually receive item as a list of item as one of its property item list. Okay. All right, so now you can actually build the client and it works okay as expected here. Okay. And now let's take a look at the generated artifact. So this is again top-down approach. I'm sorry, the bottom-up approach. So we generate WSDL document. Okay. So this is the XML schema being imported. Okay. So let's take a look at the XML schema first. So this is XML schema. So what gets generated is purchase order, and we also have an item complex type. So purchase order and item complex type and shipment notice complex type. And we also have invalid PO exception. And then we have a PO response. Okay. And then we have global elements that are actually using using these types. Okay. So this is the declaration and this is the definition of types. Okay. So inside the WSDL document, we imported that XML, okay, and then we have input message and output message, okay. So here we are actually, referencing a global element, submit a PO, which is this guy, which is the submit PO type, okay. All right. Inside is actually using purchase order type, okay. And then we have a purchase order response, which is the purchase order response. Wait a minute. Oh, I'm sorry, the submit PO response. I misunderstood. Okay, so submit PO response. So these are the two elements that are being used in WSDL document, and this is for exception. Okay. And so, SOAP message that gets generated, you can see this is, the list of items, okay, and then customer number and order number, okay, and which is actually reflecting purchase order, and then this is actually the purchase order response, okay. So again, it contains a list of items, and then it's a shipment number, okay. So we are going to actually learn this data binding in a bit more detail, but I want you to get the taste of how these complex data types are in fact being handled within JAX Web Services application. Okay. All right. So I'm going to give you guys about 10 minutes to try. Yeah, maybe I'll give you 7 minutes to try this exercise. So far what we have done was building and accessing contract last or bottom-up approach web service. Okay, so here we are going to learn how to do contract first and sometimes called the top-down web service development. So here we create WSDL document first, and then we create the skeleton code from it. Okay, and then we are going to and then client should work the same. Okay, so as long as client has a WSDL document, then client doesn't care how the service was created, top-down approach or bottom-up approach. Okay, so contract first web service. Create XML schema and then web services description language document. And you're going to use WS import to generate Java skeleton code from WSDL. Okay. And then you're going to add the business logic to skeleton code. So you use in a contract last approach. Yeah, actually, I think I gave you wrong information. On the server side, you're going to use WSGen to generate WSDL from the Java code. Okay. On the client side, it's always using WS import to generate Java code from WSDL. On the server side, if you have a WSDL, you're going to use WS import. Okay, so to generate the Java code. So WS import is used on both and server and client side from WSDL. Okay. If you're using on the server side, it's going to generate the skeleton code. If you're using on the client side, it's going to use the stub code. All right, so here we are going to actually develop the same application so far what we have done, like add numbers. And this time we are going to have a WSDL document first, and then we are going to generate the code, and then we are going to deploy the service. So pretty much the same, the business logic. Okay, so let's take a look at the exercise 6. So we have ready to build and run application called the From WSDL Server NetBeans project. Okay, and as you can see, it already has WSDL document. Okay, so if you build and run, and it will display this the WSDL document, but you can and also test it. Okay, but there is a add numbers WSDL document already provided. Okay, so let's actually take a look at that. So this is the from WSDL server. Okay, so here if you take a look at the web services WebINF and WSDL, so this is the WSDL document that is already provided. Okay, and here we are going to use WS import to create a Java code. Okay, well, what we are going to do first is in exercise 6, we're going to just build and run the application. In exercise 7, we're going to actually go through step by step to rebuild this application from scratch. Okay, so 6 and 7 are in fact the same code, but in 6 is ready to build and run application, and 7 is we are going to build step by step. Okay, so this is WSDL document that we already have. So here we have XML schema on the types element. Okay, so this is the same logic, add number response, add numbers, and add numbers fault. Okay, and then we have a global element. Okay, for each of this, so we have a global element, add numbers response, and add numbers fault. Okay, and then this is the code that got generated, and then you probably add some business logic here. So, as you can see, it generate the code using this annotation. Okay, so this is the code that got generated, and of course you are going to add this business logic yourself, right? Okay. So other than that, these things should be generated by the WS import, the underneath. And the client code should be the same. So client code doesn't matter, whether the server was created top down or bottom up. Okay. And the artifacts generate. Yeah. So this is a client code. So nothing really to learn. So in exercise 7, now we are going to actually, do a top down approach step by step. Okay. So here we are going to build from WSDL. So we are going to create the brand new web application project. Okay. I mean, you can create the Eclipse project, doing the same thing. Okay, except that you might have to actually, run WS import yourself at the command line, or if you're actually building Maven project, then you can actually add that instruction in your Maven, and then you can actually run it within Eclipse. Okay. All right, so we are going to create the web application called the from WSDL server my own. Okay. And then we are going to copy the WSDL, we are going to actually copy WSDL document from that previous project. Okay, so we're going to just copy from, so we're going to actually copy WSDL directory that contains WSDL document from WSDL server project to WSDL server my own project. Okay, so we paste it, so we have that WSDL document. Okay. Now what you can do is, you can actually create web service from WSDL. So you can say, right click and new and web service from WSDL. So what it does is that it's going to use, and then you have to provide WSDL document. So you specify WSDL document here, right? Okay. And what it does is that it's going to use WS import utility to generate the code. Okay. So, once you've done this, you can actually see the code has been generated. These are the code that gets generated. You can see this is skeleton code. There is no business logic, okay? But it does have all this skeleton code that you can use right away, right? So basically now you're going to add this business logic. You can just copy this code from, again, the exercise 6 project, okay? So basically business logic is added here. And then you can just build and run the application. Okay, and then it should work exactly the same as project 6. All right. Okay, so I am going to customize the WS build. So in NetBeans, it's using Ant internally. Okay, and the Ant script is kind of provided in which is going to actually use WS import. Okay, so here you can just take a look at the here we are basically changing the names of the project. So this is probably not much of a big deal. So you can just skip the exercise 7.2. Actually, the thing I should actually add is to build the skeleton code from the command line WS import, so that you guys can actually know what is being done underneath. Okay, yeah, that's something I'm going to actually add in the future. Okay. So you can actually skip the 7.2, and 7.3 is again, the client application. It should work exactly the same. Get the WSDL document, and then, you should be all set to invoke the service. Okay. All right. So I'm going to give you 10 minutes to do this exercise. Next topic is document literal wrapped convention. So as I mentioned before, document literal is recommended, the style and encoding for your web application. So that's what you should use. However, even when you are using document literal, there are two parameter style that you can use. One is what is called the wrapped. The other one is what is called the bare. And wrapped is the default, and this is what you have seen so far. Okay. Whether you are using wrapped or bare, you have to follow the rules defined for document literal. Okay. Again, by rules, I'm talking about rules defined in WSI basic profile. We are going to actually talk about WSI basic profile later on day 5, but it basically is recommended rules to follow by the web services implementation vendors. Okay, all right, and also actually developers as well. So when defining document literal web service, there can be at most one body part on input message and at most one body part on your output message. It kind of indicates that whatever you happen to have in your sub body should reflect the XML message that is captured in one single part, and this part should actually reflect the an element that is a complex type. Okay. And in both the input message, request message and the response message. And in other words, you do not define each method parameter as a separate part in method message definition. So you might actually see multiple parts in your message. That is a case when you're using RPC style. And when you're using document style, then you are going to see a single part. Okay. Because you do not want to actually have a multiple global element, one single global element that represent the complete XML message. Okay, so now each part definition must reference an element. So this is again something I mentioned I think once. In your message definition, you should actually point to an element, not a type. Okay, so what that means is that in WSDL document, the XML the types element of your WSDL document, meaning XML schema document, there should be a type and there should be an element that reference to that type. And in your message definition of WSDL document, you have to use the element, not the type. Okay, so that's what I'm saying in this bullet. Each part definition must reference an element, not a type, defined, imported, and included in the type section of WSDL document or separate XML schema document. Okay, so again, this is based on WSI basic profile recommendation. Okay, so wrapped parameter style is the default. Again, this is what we have seen so far. Okay, so wrapper element must be defined as a complex type. There is a sequence of elements, and each child element in that sequence will be generated as a parameter in the service interface. And the name of the input wrapper element must be the same as the operation name. And the name of the output wrapper element should be the operation name appended with the response. So this is in fact the difference between wrap parameter style and from the bare parameter style we are going to see later on. So let's see an example. So we are talking about wrapped parameter style, which is the default. So in wrapped parameter style, the XML schema that is used is you should actually use an element called the say hello, and then this is the response element is going to be say hello and response. Okay, and then these guys should have a type like this. Okay, so this is wrapped parameter style. Okay, now in wrapper parameter style in WSDLs, as you can see, document literal always have to have a single part, both in request and response message. Okay, and here is referencing say hello and hello response. Okay, all right. And this is the Java code for the wrapped. Again, this is a default. Okay, so you don't have to specify any of this. Okay, so document style is the default, literal encoding is the default, and parameter style wrap is the default. So you can specify like this, or you don't have to specify it at all because those are default. Okay. All right. Bare parameter style, on the other hand, is that there is no wrapper. Only payload is passed to service. So there can be used only one. So this can be used only when there is a single parameter. Okay, so in general, if you happen to have multiple parameters, they have to be actually captured in the wrapper style. Okay, but when you have a single parameter, you can use a bare style. So if you're using if you have a say hello, and then if you're using bare parameter style, but you happen to have a multiple parameters, then this is going to cause an exception. Okay, because you cannot use bare style when you have a multiple parameters. Okay. All right, so let's do exercise 8. So exercise 8 is, uh, so we're going to try the wrapped style and bare style. Okay, so here we are again using the bottom up approach. So we create the web service first. Okay, so this is the Java code in which we specify parameter style wrapped. Again, this is a default. Okay, so the WSDL document that gets created is going to be like a say hello response, and then we have say hello element whose complex type should actually reflect if you take a look at the XSD, the say hello element should actually reflect all the parameters, okay, as a one single complex type. Okay, so one is the arg0 and arg1. Okay, and then SOAP message should have say hello and say hello wrapper, and then the internally has the arg1 and arg2. Those are the parts. Okay? And, I'm sorry, there is a single part, but inside a part it will have these two sub elements. Okay, and this is return. So that is for the wrapper style. The bare style, if you specify bare, and then you have to make sure the method could have only a single argument, otherwise it's an exception. Now in this case, we have the WSDL document is pretty much the same. Okay, so we have the say hello response, and then we have a say hello right here. Okay, and then we have XML schema, which is a say hello is the just the string type and string type. Okay, all right. Now what is different is the SOAP message. In the SOAP message, you can see it just contains this single content. It doesn't have any wrapper. If you actually compare this guy in the SOAP message over here, you can see SOAP body have a say hello and say hello response, right? In the bare document style, it doesn't have this say hello and say hello response. Instead, it will just contain the content. So if you go back here, it will just contain the sanction and hello sanction. Okay. Again, this could be used only when you have a single parameter on your service. Okay. All right. So I'm going to give you guys about 5 minutes to try this exercise, and we have more presentation to go. Next topic is tools. So here we're going to actually learn more about the WS import and WS gen. So WS gen is again from JDK, and it generates necessary portable artifacts required for JAX-WS Services application when starting from Java code. So this is used for generating WSDL document when you're using WSDL argument, and it actually generate all the Java classes, including JAX-B classes, which means any classes that contains JAX-B annotations like a complex types. Okay. All right. So WSGen is for creating WSDL and Java classes. So this is an example. So here when we say WSDL and -d is the destination, and this is my class path, and this is the service. So assuming the stock service has web service annotation, okay, it will generate all the code, but it doesn't generate WSDL yet. Okay, so you have to specify -WSDL in order to generate WSDL document. Okay, so it generates all the Java classes plus WSDL in this case. So generate WSDL and schema for your Java class stock service, and this stock service annotated with the web service annotation. If you want to generate SOAP 1.2 based with WSDL, then you can say WSDL SOAP 1.2 like this. Okay. All right. So that is WSGen. WS import is used in two different places, one in server and one in client, right? Okay. So when you're using in, let's say, server, it will generate skeleton codes. So it generates the necessary portable artifacts required for JAX-WS Services application when starting from WSDL, top-down approach. So it will generate the service endpoint interface and service extension class and exception class and again JAX-B generated value types. Okay, so it's basically mapping Java classes from schema types. Okay, so this is an example. So here I say WS import minus P, that is the package that you want to create. So we have a single package called the stock code. Okay, and then this is the WSDL. All right, so it generate Java artifacts and compile them into importing WSDL. Okay, and again, this is for creating. Yeah, so this is actually for the creating skeleton code. And the other implementations have their own tools, like Apache Axis has WSDL to Java, and this one is WSDL to Java. Yeah, so it basically works pretty much the same. Okay. All right, so let's actually try to create, use the WS import. It's not in the hands-on lab. I'm going to actually add this one in the hands-on lab. So I think one of you did have a problem of creating I think who was that? It was, yeah, Press Shanti says that he was having a problem actually creating add numbers fault class. So let's actually try to generate using WS import. So I have already, I just copy this file from, from the sample application. This is where I want to go. So what I want to do is WS import. So I have add numbers WSDL. So this is from that, the exercise 6. Okay. So WS import and minus P. And I'm going to say, I'm going to just use jpassion.com as a package. And then I'm going to use add numbers, WSDL. Okay. And let's see how, what packages and classes are being generated. All right, so it's generated. Okay, so let's take a look at this package. Okay, so this is the package that was generated, jpassion.com. I should say com.jpassion, but anyway. Oh, what is this? Didn't actually create nothing. I lied to you. So what did I do wrong? WS import. Let me just use WS import. Okay, so WS import and add WS WS import. You specify add numbers WSDL and oh, okay, so you have to specify the destination. Destination, I'm gonna say generated. I thought actually P is supposed to be the package, I believe. P is a package, so we can use minus P and com J passion. Oops. Okay, so let's try one more time. Why I didn't like it? WS input. I'm gonna just say minus D generated. It should not matter. I'm gonna just say What am I doing wrong here? WS import, add numbers, WSDL, and SD. This is so puzzling. A directory not found. Generate. Oh, I have to actually have a directory. Okay, so let me just create the generated. Okay. Okay, now it's doing it. All right, so now let's see whether it's actually having generated. Okay, so generated. Okay, that's better. OLG example Duke still doesn't actually have a Java file. Oh, it does create the class. Okay, good. Yeah, so it didn't, yeah, it create the add fault number class. Okay, so yeah, so it did create the add numbers. Okay, all right, so that actually, oh, it didn't actually create the Java classes, but it just create the class classes. Okay, so I think if you want to actually preserve, if you want to actually preserve the Java code, I think there is another option. Okay, so you can see the Java code as well. Okay. All right, so hopefully that actually gives you a sense of how WS import is actually being used. Okay, let me see whether the question was actually the last item is catalog file. So what is a catalog file for? So one of the problems with using a tool like NetBeans, for example, to generate web service is that when you create the new web service client, you are asked to select the web service which is normally on your local machine. Okay. This means that web service has to have an address of localhost 8080. So when you try to deploy your application, your web service application on the net, okay, this localhost 8080 is not there anymore. So one way around is to use a catalog to resolve the address at runtime. So this is file, the JAX Web Services catalog.xml file, and if it is placed in meta-inf directory, basically when you have that file like this, okay, so it's actually JAX Web Services catalog.xml file, okay. Instead of actually going over here, it will try to go over here. So you have URI start string and rewrite a prefix. Okay, so this search is for any URL that start with the localhost 8080 and replace it with this. Okay, so it will actually get the correct WSDL document from the correctly located web service. Okay, all right, so a bit of convenience feature. It's not part of the JAX Web Services. Yeah, I think it's actually mentioned JAX Web Services as a specification. All right, so that was a pretty long